Okay, so in this lesson we're going to talk about patterns and inductive reasoning. So inductive reasoning is reasoning that makes broad generalizations from specific observations. So we're going to look at specific observations of patterns to help us make predictions in those patterns. So if we look at number 1, it says, do the numbers in this pattern, okay? Do they increase or decrease? They're going from 45 to 40 to 35 to 30. These numbers decrease. So you can circle that, you can highlight it, whatever you choose. Number 2 says, does the amount of change vary or does it remain constant? Well, since this is going down by 5 from term to term, that amount of change remains constant. After that, we're looking at what operation helps us go from one term to the next. It's going to be subtraction. And the value we're subtracting to form the next term is we're subtracting 5. So from the beginning, you can kind of tell it's going down by 5. So the next term after 30 is 25. The term after that is going to be 20. So that example just had us use inductive reasoning to extend a pattern. And we're going to do the same thing in example 2, except in this example, we're going to not be using numbers. We're using letters in a pattern. So it asks, what conjecture can you make about the 21st term? So moving ahead to example 3, we're going to talk about collecting information to make another conjecture. It asks, what conjecture can you make about the sum of the first 30 odd numbers? And we're going to use this table to help because it's a lot to unpack. So the sum of the first 30 odd numbers. The first term is the first odd number, 1. The second term is the sum of the first 2 odd numbers, 1 plus 3. And it's noticing that 1 plus 3 is really 4, which is 2 times 2. If we do the sum of the first 3 odd numbers, that'll be 1 plus 3 plus 5, which is 9. And 9 is really 3 times 3. The sum of the first 4 odd numbers, 1 plus 3 plus 5 plus 7, That's 16, which is really 4 times 4. And then finally, the sum of the first 5 odd numbers, 1 plus 3 plus 5 plus 7 plus 9, which is 25, or 5 times 5. So the pattern I'd like you to notice is that the first term is 1 squared, second term, 2 squared, third term, 3 squared, fourth term, 4 squared, fifth term, 5 squared. So the 30th term is going to be 30 squared, or 900. So that means the sum of the first 30 odd numbers, we have a shortcut for finding that. It's 30 squared. Instead of me doing 1 plus 3 plus 5 plus 7 plus 9 plus 11 and so on, I have a shortcut. That's the idea. That's the conjecture I can make. It's kind of like a shortcut when you're looking at a pattern, but it's more or less making a prediction or making a conclusion based on evidence. So the last example is talking about making another prediction, another conjecture. And we're talking about backpack sales based on this graph. So this graph, does it show a distinct pattern of points? I think it shows a good enough pattern of points that we can make a prediction. Each month, the number of backpacks sold doesn't increase, looks like it's decreasing. The change in sales varies from month to month, meaning it doesn't decrease by a uniform amount. I'm going to say that's true. It's not an exact amount, it's changing. If the sales change by about 500 each month, we can subtract 500 months from April's sales to get May's sales. I think that's true. It's roughly $500 on average. If the sales change by about 500 a month, you can add 500 from May's to estimate June's. I think that's false. From May to June, I'm expecting it to decrease again. So to make a conjecture about backpack sales in June, I'm looking at April. April, we sold around 8,500. So in May, we should sell around 8,000, okay? So to find June, I would take 8,000 minus 500. So about 7,500 backpacks would be sold in June. That's what we'd predict. It's not going to be exact, but that's our best approximation based on the information. So the last example is finding something called a counterexample. And a counterexample simply is just an example that disproves a statement or a conjecture. So we read this conjecture or this statement. If a flower is red, then it's a rose. We know that that's not true for all flowers that are red, that they have to be roses. So a counterexample would be a flower that is red, but is not a rose. So there's a lot of counterexamples to this. First thing that comes to my mind, I think I've seen red tulips before. So a tulip would be a counterexample. I think poppies, I think those are red. So any flower, I think there's some orchids that are red. But any flower that's red, that's not a rose. That's all a counterexample is. It's a statement that disproves another statement, or an example that disproves another statement. So this should be enough to go off of for you to do the practice. So just remember those terms, conjecture and counterexample, because those are going to be referenced throughout this chapter.